Good day all. In this lecture, I am planning to discuss about the subject signals and systems. So to start with, what is a signal? A signal is a physical quantity which varies with time, space or any other independent variable. So to start with a basic signal, if we look at it is a unit step signal. So the unit step signal is represented by u of t. So u of t is equivalent to 1 for t greater than equivalent to 0 and 0 for t lesser than 0. It is represented by this graph. So the x-axis is represented as t and the y-axis is represented by the amplitude. Since u of t occurs only from 0 to some infinity, so from 0 it will have the amplitude 1. So it goes on till infinity. So in discrete time, so here this u of t is a continuous time. Here this u of n is a discrete time signal. So in discrete time, u of n is equivalent to 1 for n greater than equivalent to 0 and 0 for n lesser than 0. So in graphical representation, u of n occurs only at discrete instance of time. Because it is a discrete time signal, only a discrete instance of time it will occur. Now, in this section, we will discuss about the time shifting operations in u of t. So, the basic time shifting operations are delay and advance. So, here this u of t minus 2 it delays the signal by 2 units. From this u of t, from 0 to 2 units, it will delay the signal. Whereas if we put u of t plus 2, it will advance the signal by 2 units. Now we will consider the time reversal operation of this basic signal u of t. So here we take this u of t, it is plotted from 0 to infinity. The amplitude is 1. So the time reversal is just the folding of the signal with reference to this y-axis. So whatever is there present in the positive side will come to the negative side, and whatever is present in the negative side will come to the positive side. So here this u of minus t is represented by this signal. That is, in the positive side, this one comes to this negative side. So this is our u of minus t, that is time reversed version of u of t. So now time reversal combined with shifting, there is a change here. So for the time reversed signal, the delay and advance will be the opposite of the basic time shifting operation. So if I write u of minus t plus 1, it is the time reversed version plus 1. So it is advanced in our basic time shifting operation. But here it is the delay. It is the reverse. So minus t plus 1 will be 1 unit. From here it will delay by another 1 unit. So here minus t minus 1 will advance by 1 unit. That is, it will go to minus 1. Now we will discuss about the amplitude scaling of this basic signal u of t. So now here basically if I say u of t, it is 1 into u of t. So here I am amplitude scaling. I am multiplying the u of t by 3. So now the u of t is amplitude scaled by 3. It means that only the amplitude is multiplied by 3. So it becomes 3 into u of t. So the amplitude only will get affected, it will increase and it will not affect the time axis. The next one example is minus u of t. So here if I say minus u of t, it means that it is minus 1 into u of t. So you should always understand that there is a difference between u of minus t and minus u of t. U of minus t is time reversal. Minus 1 into u of t is just amplitude scaling by minus 1. So we get the minus u up. So if 1 into minus 1 will give us minus 1. So minus 1 into u of t is the given signal. Now we'll move on to the signal addition. So signal addition, when the two signals we had discussed here, 3 into u of t minus u of t. So these two we will add now. So 3 into u of t minus u of t. So the amplitude, if I mean by signal addition, only the amplitude will get added. So here 3 minus 1. So it gives 2. So here the resultant signal will be represented like this, 3 into u of t minus u of t. So this is our resultant signal for this signal addition. So next operation is signal multiplication. So here the same signal what we had discussed earlier, that is 3 into u of t into minus u of t. So the same signal is done, the same signal we will do signal multiplication. So here this is u of 3 u of t. This is 3 u of t. We had plotted here. And here this one is, the signal is minus u of t. So here if we note down here, this is this 3 and minus 1 alone are multiplied. So 3 into minus 1 gives minus 3. So here we have plotted minus 3 here. That is, the amplitude is minus 3. So this is the resultant signal, 3 into u of t into minus u of t. This is the result of this signal multiplication. Now let us consider this example, minus 2 into u of t minus 1. So first we need to plot this u of t. So here two operations are combined, that is time shifting and amplitude scaling. So here u of t, first we will plot u of t, which is 1, amplitude is 1 from t is equivalent to 0 to infinity. Then we need to plot u of t minus 1. Then we need to plot u of t minus 1. So it is shifted by 1 unit. Then we need to multiply with this 2, minus 2. We need to multiply the amplitude by minus 2. So here amplitude of u of t minus 1 is 1. So 1 into minus 2 will give us minus 2 is the amplitude. So this is our resultant signal for minus 2 into u of t minus 1. So now we will consider this example, 2 into u of n minus 1 plus 2 in u of n plus 1. Here u of n is a discrete time signal. So here this u of n is represented by discrete 1, amplitude 1 at discrete instance of time. So now we need to do this operation, that is u of n minus 1. So u of n minus 1, so u of n is shifted by 1 unit, that is delayed by 1 unit. So from 1 it will start. Then it has to be amplitude scaled by 2 units. So 2 into u of n minus 1. So the amplitude will become 2. Amplitude alone from 1 it will become 2, and this amplitude will start from 1. That is n is equivalent to 1. Here you have to notice that because it is discrete time, then t is changed as n. And then the second signal is u of n plus 1. So because it is n plus 1, it is advanced. U of n is advanced by 1 unit. So the signal starts from minus 1. So here, so we have two signals, that is 2 into u of n minus 1 plus u of n plus 2. So two signals we have. Now we need to add these two signals. So how we need to add? We need to just check here. See here, at n is equivalent to minus 1, we have to check for all instances of this n. So till this it is 0. At n is equivalent to minus 1, here we have amplitude is 1. So it will 1 plus, here it is 0. So 1 plus 0 is 1. And here at 0 what will happen? So here we have a 1 here, and this 1 plus the 0 will give us 1 again. And then at 1 what happens? Here we have a 1 in this u of n plus 1. Here this 2u of n minus 1 we have a 2. So this 2 plus 1 will give us 3. So here, from here it is 3. That is, from n is equivalent to 1, it is 3 for this signal. So till infinity it will go on, and till infinity it is 3, amplitude is 3. So this is the resultant signal. So here in this lecture we had discussed what is a unit step signal and what are the basic operations of this with this unit step signal, that is time shifting, time reversal, amplitude scaling, signal addition, signal multiplication for both continuous time and discrete time we had discussed. Thank you.